Good day, sir. My name is Karl Mamac from 3BSCEA. And this is my discussion on my first assignment in the Principles of Steel Design. For the problem 2.1, a column in the upper story of a building is subjected to a compressive load from the following sources. Dead load is equals to 30.8 kips. Occupancy live load is equals to 1.7 kips. Roof live load is equals to 18.7 kips, and snow load is equals to 19.17 kips. And here are the 5 sub-question in the problem 2.1. First is letter A. If load and resistance factor design is used, determine the factored load or the required strength to be used in the design of the column which AISC load combination controls. So for the given, D is equals to 30.8 kips, L is equals to 1.7 kips, LR or the roof live load is equals to 18.7 kips, the snow load is equals to 19.7 kips. So for the combination 1 equals to 1.4 multiplied to dead load. So by substituting the dead load by 30.8, we makakuha tayo ng 43.12 kips. So for the combination 2, 1.2D plus 1.6L plus 0.5 multiplied to LR or S or R. By substituting this by the given, we can get 49.53 kips. So dito, ang kinuha natin dito is 19.7 because the snow load has the highest value among the other, the LR or the rain load. So for the next combination 3, 1.2 multiplied to dead load plus 1.6 multiplied to roof live load or the snow load or rain load plus 0.5 multiplied to live load or the wind load. So next, substitute by the given, we can get 69.33 kips. So dito, ang kinuha natin dito is 19.7, which is the snow load, kasi nga mas malaki siya sa roof live load or sa rain load. Dito is ang live load kasi wala tayong wind load. So among those combination, the combination 3 is the control, and the factored load or the required strength is equals to 69.3 kips. So for the next question, what is the required design strength of the column? So since the required strength is less than or equal to design strength, so the design strength is equals to 69.33 kips. For next, letter C, what is the required nominal strength of the column for a resistance factor F of 0.90? So Pn is equals to design strength over resistance factor. So by substituting it, we can get 69.33 over 0.90, and by dividing it, we can get the nominal strength is equals to 77.03 kips. So for the next question, letter D, if allowable strength design is used, determine the required load capacity to be used in the design of the column, which American Institute of Steel Construction load combination controls. So for the combination 1, which is the D or the dead load, is equals to 30.8 kips. Combination 2, D plus L equals to 30.8 plus 1.7 equals to 32.5 kips. So for the combination 3, which is the D plus LR or S or R, is equals to 30.8 plus 19.7 sa snow load kasi ito yung pinakamataas na value. So equals to 50.5 kips. For the combination 4, D dead load plus 0.75 live load plus 0.75 roof live load or snow or rain load is equals to 30.8 plus 0.75 multiplied to 1.7 plus 0.75 multiplied to snow load, since malaki nga siya kaysa sa roof live load or sa rain load, is equals to 50.5 kips. So the load combination control is the combination 3, and the load capacity is 50.5 kips. For the next question, what is the required nominal strength of the column for safety factor of 1.67? Since the required load capacity is less than or equal to nominal strength over safety factor, by deriving the formula, we can get the required nominal strength is equals to safety factor multiplied to required load capacity. By substituting the variables, we can get 1.67 multiplied by 50.5. We can get the required nominal strength for the column of 84.3 kips. So for problem number 2, a column is subjected to the following loads. Dead load is equals to 26 kips. Occupancy live load is equals to 15 kips. Roof live load is equals to 5 kips. Snow load is equals to 8 kips. Rain load is equals to 5 kips. And wind load is equals to 8 kips. All loads are compression except for the wind load, which can be either tension or compression. In this problem, there are 5 sub-question. So for the next question, which is the letter A, if load and resistance factor design is used, determine the factored load to be used in the design of the column. Which AISC load combination controls? Given the dead load is equals to 26 kips, live load is equals to 15 kips, roof live load is equals to 5 kips, snow load 8 kips, rain load 5 kips, and wind load equals to 8 kips. For the combination 1, 1.4 multiplied to D, substitute, we can get 36.4 kips. For the combination 2, 1.2D plus 1.6L plus 0.5 LR or S or R, and we choose the highest value for this given. We can get 1.26, 1.2 multiplied to 26 plus 1.6 multiplied to 15 plus 0.5 multiplied to 8, which is the wind load or the snow load rather. We can get 59.2 kips. For combination 3, 1.2D plus 1.6 LR or S or R plus 0.5 L or R. By substituting the following variable, we can get 51.5 kips. Combination 4, 1.2D plus 10W plus L plus 0.5 LR or S or R. By substituting the following and choosing the highest among the choices, highest value among the choices is, we can get 50.7 kips. So since the combination 2 has the highest the factored load, so the combination 2 is the control, and the factored load is 59.2 kips. Next, for the letter B, what is required design strength of the column? Since PU or the required strength is less than or equal to design strength, so the design strength is equals to 59.2 kips. For letter C, what is the required nominal strength of the column for a resistance factor F of 90, 0.90. So the required nominal strength is equals to design strength over the resistance factor. By substituting it, can get 59.2 over 0.90, and we can get Pn, or the nominal strength of the column, is equals to 65.78 kips. If allowable strength design is used, determine the required load capacity to be used in the design of the column, which EISC load combination controls. Combination 1, which is the D, is equals to 26 kips. Combination 2, dead load plus live load. By substitute, we can get 41 kips. Combination 3, dead load plus either roof live load or snow load or rain load. We choose snow load since it has the highest value. Then substitute equals to 34 kips. Combination 4, dead load plus 0.75 live load plus 0.75 multiplied to snow load since it has the highest, equals to 43.25 kips. Combination 5, dead load plus 0.6 wind load or 0.7 earthquake load. Substitute, we choose the 0.6 multiplied to wind load since we don't have earthquake load, then equals to 30.8 kips. So combination 6A, D plus 0.75 L plus 0.75 multiplied to 0.6 wind load plus 0.75 LR or S or R, or we choose here the S equals to 8. Then substitute the other remaining variables and we can get 46.85 kips. So the combination 6A is the control since it has the highest load capacity, and the required load capacity is equals to 46.85 kips. For the next question, letter E, what is the required nominal strength of the column for a safety factor of 1.67? PA, or the required load capacity, is less than or equal to nominal strength over the safety factor. Then derive the formula, equals to nominal strength equals to safety factor multiplied to required load capacity, equals to 1.67 multiplied to 46.85. We can get the nominal strength is equals to 78.2 kips. So next problem is the problem 2.3. The loads on a roof beam consist of a dead load of 0.2 kips per foot, a roof live load of 0.13 kips per foot, and a snow load of 0.14 kips per foot. So this is the sub-question A and the sub-question B. For the sub-question A, if load and resistance factor design is used, determine the factored load to be used in the design of this beam, which EISC load combination controls. Given dead load is equals to 0.2 kips per foot, roof live load is equals to 0.13 kips per foot, snow load is equals to 0.14 kips per foot. So combination 1, 1.4 multiplied to D is equals to 0.28 kips per foot. Combination 2, 1.2D plus 1.6L plus 0.5 roof live load or snow load or rain load. So we choose 0.14 as the snow load. Then substitute the D and L. We can get 0.31 kips per foot. So combination 3, 1.2D multiplied plus 1.6 multiplied to LR or S or R plus 0.5 L or W. Here we ginamit natin ang snow load dito kasi malaki ang kanyang value. Then dito is 0 since wala tayong live load or the wind load. So we can get 0.464 kips per foot. So combination 3 controls since it has the highest value among other combination. Then the required factored load is equals to 0.464 kips per foot. Next, if allowable strength design is used, determine the required load capacity to be used in the design of the column, which EISC load combination controls. Combination 1 D, which is 0.2 kips per foot. Combination 2 D plus L is equals to 0.2 plus 0 since we don't have live load. So we can get 0.2 kips per foot. Combination 3 D plus LR or S or R. So we choose here the snow load since it has the highest value. Then we can get 0.34 kips per foot. So combination 3 is the control. And the required load capacity is equals to 0.34 kips per foot. So for the next problem 2.4, beams will be designed for the roof and floor systems of an office building. The loads for these systems are as follows. Roof equals to dead load is equals to 30 PSF. Roof live load is equals to 20 PSF or the pounds per square foot. Snow load is equal to 21 PSF and a rain load consisting of 4 inches of water. So floor dead load is equals to 62 PSF and occupancy live load is equals to 80 PSF. So we have here this sub question A and the sub question B. For each of this system, determine the required factored load capacity for LRFD, which load combination controls. Given for the roof, dead load is equal to 30 PSF, LR is equals to 20 PSF, snow load is equals to 21 PSF, rain load is equals to 4/12 multiplied by 62.4, the density of water, then equals to 20.8 PSF. Combination 1, 1.4 multiplied by D is equals to 1.4 multiplied by 30 equals to 42 PSF. Combination 2, 1.2 D plus 1.6 L plus 0.5 multiplied by LR or S or R. Ginamit natin dito is snow load since malaki siya. Then next, substitute lang natin ang value. Then makuha natin ang 46.5 PSF. For combination 3, 1.2 multiplied by D plus 1.6 multiplied by LR or S or R plus 0.5 L or W equals to substitute 1.2 multiplied by 30, 1.6 multiplied by 21 since malaki ang snow load ginamit natin, plus 0.5 multiplied by 0 since wala tayong live load and wind load. We can get 69.6 PSF. Among the controls, the combination 3 is our control, and the required factored load capacity is equals to 69.6 PSF. Next, for the given, which is the floor, D is equals to 62 PSF and live load is equals to 80 PSF. Combination 1, 1.4 multiplied by D, which is 62 PSF, is equals to 86.8 PSF. So for the combination 2, 1.2D plus 1.6L plus 0.5 multiplied by LR or S or R, by substituting, dead load is 62, live load is 80, and here is 0 since we don't have roof, live load, snow load, or rain load. And adding and multiplying, we can get 202 PSF. So combination 2 is the controls, and PU is equals to 202 PSF. For question B, for each of these system, determine the required ESD load capacity which load combination controls. Combination 1, D equals to 62 PSF. Combination 2, D plus L is equals to 62 plus 80 equals to 142 PSF. So the combination 2 is the control, and the required load capacity is 142 PSF rather. So for problem 2.5, structural steel buildings frequently are designed with diagonal bracing systems to resist lateral loads. A certain bracing system is subjected to the following loads. Dead load is equals to 13.3 kips, occupancy live load is equal to 6.9 kips, roof live load is equals to 1.3 kips, snow load is equals to 1.3 kips, wind load is equals to 150.6 kips, and earthquake load is equals to 161.1 kips. So for sub-question A, sub-question B. For sub-question A, determine the required factored load capacity for LRFD which load combination controls. Given data is equals to D is equals to 13.3 kips, L equals to 6.9 kips, LR or the roof live load is equals to 1.3 kips, snow load is equals to 1.3 kips, wind load 150.6 kips, earthquake load 161.1 kips, and for the combination 1, 1.4 multiplied by D equals to 18.62 kips. Combination 2, 1.2D plus 1.6 plus 0.5 LR or S or R. Dito ginamit natin dito is the LR or the SR since they have the same value, and by calculating we can get 27.65 kips. Combination 3, 1.2D plus 1.6 multiplied by LR or S or R plus 0.5 L or W equals to, dito ginamit natin dito is 1.3 since same dun sa combination 2, and dito ang ginamit natin dito is wind load since mas malaki ang wind load natin kaysa sa live load. Pag kinumpute natin yan, ang lalabas is 93.34 kips. So for combination 4, 1.2D plus 1.0 multiplied by W plus 0.5L plus 0.5 multiplied by LR. So substitute din natin, ang lalabas na value is 170.7 kips. So for combination 5, 1.2D plus 1.0 multiplied by E plus 0.5 multiplied by L plus 0.2 times S. Substitute natin, and ang lalabas na value is 180 kips. So ang ating combination control is the combination 5 since it has the highest value among other combination, and the required factor load capacity is 180 kips. So for the next is the letter B, determine the required ESD load capacity which load combination controls. Combination 1D which is equals to 13.3 kips. Combination 2 D dead load plus live load equals to, substitute, then equals to 20.2 kips. Combination 3 D plus LR or S or R, then is-substitute natin. Ang ginamit natin dito ay LR at saka S since same lang sila ng value, and ang lalabas is 14.6 kips. Combination 4 D plus 0.75 times L plus 0.75 L or S ang ating gamitin dyan kasi same lang ang value. Then, substitute natin. Ang lalabas is 19.45 kips. For the combination 5, D plus 0.6 wind load or 0.7 E. Then, substitute natin. Ang ginamit natin dito is the wind load. Earthquake rather, since it has the highest value. Then, we can get 126.1 kips. So, combination 5 controls since it has the highest value among other combination. And the required is the load capacity is 126.1 kips. So, that's all for today and thank you, sir. God bless.